Hello everybody, welcome back to learning the IGCSE curriculum with Omar. Today's video is going to be all about the Pascal's triangle as well as the binomial theorem. By the end of this video, you will see how these concepts here actually help simplify rather complex problems that many people face trouble with and have a hard time solving by themselves. So let's get started. Okay, so starting with the Pascal's triangle, let's learn what it actually is. So what is the Pascal's triangle? It is basically a triangular array of numbers where each number is the sum of the two numbers directly above it. So how do we demonstrate this? In order to demonstrate it, we can start by building the Pascal's triangle. So how do we do that? First, we're going to start by writing the number 1 on the board. Now, after we have drawn the number 1, what you want to remember is the definition of the Pascal's triangle. Like we learned, it is a triangular array of numbers, correct? So, once we move on to the next row, you're going to want to start with a new row, and then you're going to want to write a pair of ones again. So as you can see, it has already made a triangular shape over here. In the Pascal's triangle, there are subsequent rows in which each row, the beginning of a new row, starts with 1 and always ends with 1. So when we move on to the third row over here, what we're going to do is start with the number 1, and as you can see here, we have a pair, right? And as we discussed, in a Pascal's triangle, each number is the sum of the two numbers above it, two numbers directly above it. So as we can see here, if we add 1 plus 1, we're going to get 2. So we're going to write 2 down here. We have another space left, but we do not have a pair right above it. There is a number missing in this place. So we're just going to end this row with, once again, the number 1, because it always starts with 1 and ends with 1. Okay, so let's do the next row. The next row, we're going to write 1, start with 1. 1 plus 2 is 3. 2 plus 1 is again, it's 3. The order does not matter. 1 plus 2 is 2 plus 1, same thing. And then we're going to end with the number 1 again. 1, 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4 again, and then ending with 1. So that is how you build the Pascal's triangle. As you can see here, I have done it until the 5th row. Of course, this can go on until the 15th row, the 20th row, but to just get a basic understanding of the concept, we're just gonna stick to this. Now, as you can see here, you can notice the pattern in the Pascal's triangle. It always starts with 1, and then, as you can see, the diagonal line here is all ones. 1, 1, 1, 1, 1, 1, 1, right? It's because it ends with 1, it ends with 1 and starts with 1. And then you can see that the numbers here are all the sum of the two numbers right above it. So 2, we got 2 because we added 1 with 1. We got 3 because we added 2 plus 1. We got 6 because we added 3 plus 3. We got 10 because we added 6 plus 4. Now you can see 4 plus 1, 5, it's everywhere. So using this pattern, you can memorize to draw the Pascal's triangle very easily. Okay, so there are actually many different applications of the Pascal's triangle, but one of the most common places where it is applied is the binomial theorem. Now you may ask, what is the binomial theorem? It may sound unfamiliar to you, but don't worry, it is not. I am sure you know its concept. It is basically the algebraic expansion of the powers in a binomial expression. Now, in simpler terms, all that means is just expanding brackets. Expanding, like for example, let's say quadratic expressions. For example, let's say you have a plus b squared. Now, I'm sure you guys have seen this bracket before and also have learned how to expand this. We know the expanded form of this. It is equal to a squared plus 2ab plus, what is it? B squared, correct? Now let's say this bracket was not to the power of 2, but instead to the power of 6. Now how would you expand that? Now that's going to be a bit of a tricky question because that number is quite a big exponent. It's going to be hard to memorize the expanded form for a bracket to the power of such a big number, right? When you have a quadratic expression, it is easy to memorize this. Like I just said, a squared plus 2ab plus b squared, that's it. That is the expanded form. But the expanded form, for 6, could you tell me right now at the top of your head? No, you couldn't, because it is very long. So this is where you apply the Pascal's triangle. The Pascal's triangle is going to help us to expand brackets and expressions where the exponent is a large number. So let's get into it. Okay, so as you can see here, this is the Pascal's triangle, and these are all the expressions that are correspondent to each row. So a plus b to the power of 0 is going to be 1, because anything to the power of 0 is 1, right? Then a plus b to the power of 1 is this row, and then that just goes on respectively. So as you can see here, you can notice the pattern that the first row, or you could call it the 0th row because the power is 0, is 1. Then the first row is to the power of 1. The second row is to the power of 2. Third row is to the power of 3, and then so on. Now, how do we use this to expand these brackets? Now, let's say we want to expand a plus b power of 4. So as you can see here, this is the row that we're going to be using. Now, you may be asking, okay, we're going to use this row. That's fine. I understand. But what do these numbers actually mean? What does 1, 4, 6, 4, 1 have anything to do with expanding this expression right here? Now let me tell you that these numbers over here are actually the coefficients of each term in this expression. Now what does that mean? That the numbers that are going to be in front of your x and y's in your expanded form are these numbers. Okay, so in order to expand this, what we're going to start with is going to be the first coefficient, which is 1. So we're just going to draw, or not draw, we're going to write. We're going to write 1, and then we're going to write x power 4, and then y power 0. After this, the next term is going to be plus coefficient 4, x power 3, y power 1. The next term is going to be plus 6, x power 2, y power 2. Now I don't have space to continue in that direction, so I'm going to come down here. Next term is going to be 4, the coefficient 4, x power 1, y power 3. And then the last term is going to be 1, right? Because the coefficient is 1, x power 0, y power 4. Now, in order to understand what I actually did, now look at this. This is going to blow your mind. The powers you see on x, look at the pattern. They're decreasing each term by -1. The first term, it was x power 4 because the row we're looking at is to the power of 4, right? So x power 4. Then the next term, x power 3, x squared, x power 1, then x power 0. So as you can see, even from 4 to 3, 2, 1, 0, it got minused by 1 each time. Now with y, you can see we started with y power 0, and then it gradually increased by 1. Y power 0, y power 1, y squared, y cubed, y quad. Now, you want to follow this pattern for each row whenever you want to expand any of these brackets, and you're gonna easily get your expanded form. So now, of course, this isn't the simplified version because we still have the power zeros. So what is the simplified version for this? Is going to be equal to x power 4 plus 4x cube y plus 6x squared y squared plus 4 x y cubed plus x, or well, actually my mistake, it's power 0, so no x. It's just going to be y power 4. So this is your expanded form for a plus b power 4. Okay, so let's do one final example to really set the record straight. Let's do a plus b power of 5. Now how do we expand this? So let's start. We're gonna use the Pascal triangle and we're gonna look at the coefficients. The first one is 1, then x power 5 y power 0 plus 5 x power 4 y minus, not minus, y power 1 plus 10 x power 3 y power 2 plus 10 x power 2 y power 3. I'm going to move on here, no space, plus 5 x power 1 y power 4, and then finally 1 x power 0 and then y power 5. So what is the simplified version? Is going to be x power 5 plus 5x power 4y plus 10x cube y square plus 10x square y cube plus 5x y power 4, and finally y power 5. So this is the expanded form for a plus b power 5. Okay, so that's pretty much it from me, guys. Today in this video we learned the Pascal triangle as well as the binomial theorem. We learned how to build the Pascal's triangle. We learned how to apply it into expanding brackets and expanding different types of expressions, like we learned the binomial theorem. And yeah, that's pretty much it. If you guys have any further inquiries or have any confusing parts that you guys are facing trouble with, you guys can leave the questions in the comment section below. That's it from me, and see you guys in the next one. Until then.